Hello everyone. Today we will discuss about the concept of inverse trigonometric functions. Inverse trigonometric functions are the inverse of the trigonometric functions with suitably restricted domains. The inverse trigonometric functions are used to determine angle measure when at least two sides of right-angled triangle are known. Inverse trigonometric functions are widely used in engineering, navigation, physics, and geometry. In general, if we know the trigonometric ratio but not the angle, then we can use the corresponding inverse trigonometric function to find the angle. This is expressed mathematically as follows. Mathematics is not just about studying and learning formulae from book. We should also know how to apply mathematical concepts in our daily lives to make things easier. Let's try to explain the concept of inverse trigonometry with the help of a real-life example. The Leaning Tower of Pisa is an excellent example to understand the application of inverse trigonometry. It is a remarkable architectural structure from medieval Europe. The tower began to tilt during the construction due to an inadequate foundation on the ground. The tilt increased in the decades, and the rate at which the tower started to lean was such that it would have fallen with time. So, in order to preserve the historical architectural masterpiece, an international team of geotechnicians, engineers, mathematicians, structural engineers, and historians were gathered in an attempt to save the famous landmark. For this, first of all, the angle at which the tower was leaning was calculated. From the figure, we can see that the height of the tower acts as a hypotenuse and its distance from the center acts as the perpendicular. So, they had the value of perpendicular and hypotenuse. From the table of trigonometric ratios, it is clear that sin theta is equal to perpendicular upon hypotenuse, which implies sin theta is equal to 5.45 upon 58.36, which implies sin theta is equal to 0.09338, which implies theta is equal to sin inverse of 0.09338, which implies theta is equal to 5.3580 degrees. That is, theta is approximately equal to 5.4 degrees. In this way, they used the concept of inverse trigonometry to find the angle at which the tower was leaning. Therefore, the tower had to be moved by 5.4 degrees to straighten it. But the government of the city considered it very important to retain the tilt of the tower, due to the role that this element played in promoting the tourism industry of Pisa. So, it was decided that the tower should be moved a little and the foundations were reinforced and the tower itself was encircled with steel cables, due to which tower was moved by approximately 1.55 meters. As a result, the top of the tower was displaced horizontally 3.9 meters from the center and the height reduced to 56.67 meters. From the figure we can see that the height of the tower acts as a hypotenuse and its distance from the center acts as the perpendicular. So, again, they made calculations with new values of perpendicular and hypotenuse. From the table of trigonometric ratios, sin theta is equal to perpendicular upon hypotenuse, which implies sin theta is equal to 3.9 upon 56.67, which implies sin theta is equal to 0.0688, which implies theta is equal to sin inverse of 0.0688, which implies theta is equal to 3.94 degrees. That is, theta is approximately equal to 3.9 degrees. So, finally, the tower was tilted at an angle of 3.9 degrees and declared safe for the next 300 years. From the above example, we have understood the importance of mathematics in our daily lives. Moving towards the next step, you should also try to visualize things in real life from mathematical point of view, which will make learning easier and interesting. Thank you. We will meet again in the next session and discuss some other topics and try to connect them with practical examples.